Hi class, we're still on 9.3 notes day 1. Now we're going to actually be graphing these rational equations, so make sure that you take out your graphing calculator because you're going to need them in this lesson. The directions here are, it says sketch the graph of the following functions. Draw in the vertical asymptotes, the horizontal asymptotes, and the holes. So the first thing I'm going to do, class, is it asks us to draw in the vertical asymptotes, so I'm going to put that right here, the horizontal asymptotes, and the holes, which is the removable discontinuity. Let's get those three out of the way right away. So we first have to simplify our function, and if we look at this one, it's as simplified as we can make it. We can't factor the top or the bottom and reduce common factors and stuff like that, so we're already done. So my vertical asymptotes are when the denominator equals 0. So when does x minus 2 equal 0? Well, it's when x equals a positive 2. So I know I have a vertical asymptote at x equals 2. So now class, as a reminder, a vertical asymptote is a line that the graph approaches infinitely, but it never touches. We always draw those with dotted lines. So I want you guys to go to x equals 2, and I want you to draw a vertical line at x equals 2. And I want it dotted just like this. This is going to tell us that this is an asymptote. It's a line that the graph approaches, but it never touches. My removable discontinuity are holes in the graph. Those are found when factors are canceled or reduced. We didn't have any of that in this one, so we're just going to put that there are none. So there's no holes in the graph. Your horizontal asymptotes right here, these are determined by looking at the table on your graphing calculator. So for any horizontal asymptote, we must put them into our graphing calculator. So right here, let's put this into our graphing calculator. I'm going to show you how to do that. It's x divided by x minus 2. Here's what I want you guys to do. When you guys push y equals right here, I always want you to put the numerator in parentheses and then put the denominator in parentheses so that you're telling your calculator exactly what goes in the numerator and exactly what goes in the denominator. So in your numerator, you have x, so put that in parentheses. X goes in the numerator, and then you press divide, and then you put x minus 2 in the denominator, but put that in parentheses as well. So parenthesis x minus 2. So each and every rational graph that you do, put the numerator in parentheses and put the denominator in parentheses. Then you won't have any problems with your graphing calculator. Now we're going to press graph. As you can see, we have our rational graph. They look quite a bit different than we've ever really seen before. My calculator shows where the asymptote is. This line right here isn't part of the graph, it's actually an asymptote, which we already have in a dotted line on our graph. Your calculator might not show that. To be honest with you, I wish mine did not show that. I think it makes it kind of messy. But as you can see, there's our vertical asymptote, which is already written in. Now, if you're kind of looking, class, where does my horizontal asymptote appear to be? Where does this line apparently approach? And where does this line seem to approach? They approach a line but never ever touch it. That line, maybe you can see right here, is 1. It looks like it approaches the line y equals 1. So the first thing you could do is just use your eyesight and look at the graph. Where is that horizontal asymptote at? The second thing you could do besides using your eyesight is to actually use the table. So you go second, graph. Here's my function. As you can see, at x equals 2, I have an error. I should have that because there is a vertical asymptote there, right? We know that our function doesn't exist when our denominator is 0, which means that's when x equals 2. Now, I want you guys to scroll up for a while. Scroll up, up, and up, up, up. Notice how it's going from 0.7 to 0.8 to 0.86 to 0.88 to 0.889. It's getting to 0.9, 0.9. It's getting closer and closer and closer to 1. But class, I can push up forever and ever and ever until my batteries die. And it will never ever reach the value of 1. I could keep on going forever and ever. And it's never ever going to reach 1. So I know that my horizontal asymptote is the line y equals 1. I can do the same thing as I press the down button. I go down. I'm going from 1.6 to 1.5 to 1.4 to 1.2 to 1.15 to 1.13 to 1.11, 1.1, 1.0. I can keep on pressing it forever and ever and ever, and it will get closer and closer and closer to 1, but I promise you it will never, ever, ever touch 1 on the nose. It'll get close to it, but it will never ever touch it. So as you can see, our horizontal asymptote is the line y equals 1. So we're going to write that right here. Y equals 1. And we're also going to put that in a dotted line as well. Our horizontal asymptote, it's never going to touch the line y equals 1. So both of your asymptotes I want you to put with dotted lines. Now we're almost done. We just have to sketch this function. Here's what I want you to do to sketch the function. I want you to put 2 dots on the right side of the vertical asymptote, and I want you to place 2 points on the left side of the vertical asymptote. And the way you do that is you find convenient points that are found in your graphing calculator. So here's our table. Right here, let's see here. These 2 are convenient points right here. They are nice and easy to graph on our grid. So at 3, 3, and at 4, 2. Those are going to be to the right side of my asymptote. So put a point at 3, 3, and 4, 2. At right 1, 2, 3, up 1, 2, 3. And at right 4, up 2. And now you can sketch your graph. All I need to see is 2 points to the right of your vertical asymptote. So I graph this. I know it's going to follow my asymptotes. It's never going to touch them, but it's going to get closer and closer and closer to them. So that's what I have on the right side. Now I'm going to pick 2 points on the left side of my vertical asymptote. So 2 points on the left as I scroll up are going to be 0, 0, and 1, negative 1. 0, 0, and 1, negative 1. 0, 0, and 1, negative 1. Right there. And now I'm going to sketch this graph. They're not going to be perfect. Try as best you can. But that is what I expect from you on these graphs. So just to summarize, I need to see this on your test. Vertical asymptotes, horizontal asymptotes, removable discontinuity. I need to see both of the asymptotes in dotted lines. Okay, so make sure you put those in there. And then I also need to see the actual graph with 2 points to the right of the vertical asymptote, 2 points to the left of the vertical asymptote, and then just sketch your graph. It should look very similar to what you see on your graphing calculator. So that should be a good check for you. When I press graph here, this graph should look very, very similar to what you have on your graph. Okay? So that's what I expect from you. Let's try this 3 more times today. On this next one, the first thing we have to do, class, is we have to find our vertical asymptotes, our horizontal asymptotes, and our removable discontinuity. The way we do that is we first have to simplify our equation. So this is going to be the same thing as x minus 3 times x plus 3 divided by x plus 3. So now what we have is we're going to have these factors cancel. So all we're left with is the function y equals x minus 3. This is all that's left after we reduce. So class, doesn't this look kind of familiar to you? This is y equals mx plus b. This just looks like a straight line. So for our vertical asymptotes, we don't have a denominator right here, so there is none. Right? Our removable discontinuity, we do have a hole in this one. Our hole is the factor that canceled, which is the x plus 3 factor, which means our removable discontinuity is x equals a negative 3. For our horizontal asymptote, let's put this into our calculator. So we're going to put this in the numerator, in parentheses, this in the denominator, in parentheses. Let's graph that all together here on our graphing calculators. So clear this one. We're now going to have the quantity x squared minus 9 divided by the quantity x plus 3. In class, make sure you always put the original equation in your graphing calculator. Don't put the reduced one. Always put the original one in. We graph this, and as you can see, we have a straight line because after we reduce, we do have a linear function. So this linear function, as you can see, it doesn't have any horizontal asymptotes either. So we're going to put none for our horizontal asymptote. So we don't have any dotted lines on this one. And all we have here is a linear function. So at a negative 3 is our y-intercept, 1, 2, 3. We have a slope of 1. It's a rise of 1 and a run of 1. So I'm going to show you something here really quick. All we have is a straight line that goes up and to the right and down and to the left. However, there's one thing that we need to be careful of. We have a removable discontinuity at one point. Where is our hole at? Our hole is when x equals a negative 3. You can see that on your graphing calculator. Go to second graph. At x equals a negative 3, up here, as you can see, we have an error, which means that we're dividing by 0, which can never happen. So we need to designate that by using our graph paper here. At x equals a negative 3. So here's x equals a negative 1, x equals a negative 2, x equals a negative 3. We're going to have a hole right there. And now our graph is going to continue to negative 4, negative 5, negative 6, so on and so forth. So this is how your graph should look. I expect to see these three things on a test. I expect to see this line right here with a removable discontinuity at that point. Okay? All right, why don't you guys pause the video, try to do this one all on your own. After trying this on your own, you should have got y equals x minus 7 over x minus 7 times x minus 3. So, continue to simplify. Your x minus 7's cancel, and you get y equals 1 over x minus 3. So your removable discontinuity, your holes, your vertical asymptotes, your horizontal asymptotes. Vertical asymptote is x equals a positive 3. Your horizontal asymptote, we're going to find that by using our graphing calculator, and our removable discontinuity, none of the factors canceled, so there are, wait, one of the factors canceled, sorry about that, x minus 7 did, so that means x equals 7 is our removable discontinuity. We're now going to find out where our hole is by putting this in our graphing calculator. So remember, don't put this one in your graphing calculator. You want to put this one into your graphing calculator. So we're going to go to y equals. We're going to put in x minus 7 in parentheses divided by, we're going to put in that whole trinomial of x squared minus 10x plus 21. And we graph that. And as you can see, we do have our vertical asymptote at x equals 3. And we have our horizontal asymptote at y equals 0. It's the x-axis. We can check that by using our graphing calculator. I'm assuming you guys already did that, so we'll just all go together now. At y equals 0, we have a horizontal asymptote. Y equals 0. So let's draw these on our graph. At x equals 3, we have a dotted line. There's our vertical asymptote. At y equals 0, we have a horizontal line, because that is our horizontal asymptote. Now, class, all you need is 2 points to the right of your vertical asymptote and 2 points to the left of your vertical asymptote. Go to the table. See, your vertical asymptote is at a positive 3. There's positive 3. So these are the points that I'm going to draw on my graph. At 1, it's at a negative 0.5, and at 2, it's at a negative 1. So 1, negative 0.5, and at 2, it's at a negative 1. So at right 1, down 0.5, and I have a short memory. What was the other one again? At right 2, down 1. Right 2, down 1. So I'm going to connect these 2 points, and I'm going to follow my asymptotes. And so I'm going to do the same thing on the right side of the vertical asymptote. So at 4, it's at 1, and at 5, it's at 0.5. Right 4, up 1. 1, 2, 3, 4, up 1, and at right 5, up 0.5. And I am going to do the exact same thing where I'm going to follow my asymptotes. And that's how we graph that one. Those are my expectations of you when you do that problem on a test. Last one for the day. On this one, I can't cancel anything. I can't reduce any further. So I could already state my vertical asymptotes, my horizontal asymptotes, and my removable discontinuity. Vertical asymptotes. This is the same thing as x minus 1 times x minus 1. So basically, I only have one thing that x cannot equal in the denominator, and that is x equals 1. So x equals 1 is going to be my vertical asymptote. I didn't have any factors that canceled, so there is no removable discontinuity. Let's put this in our graphing calculator to see the horizontal asymptote. Y equals 4 over so put 4 in parentheses, divided by the quantity x minus 1, and that quantity squared. Graph. One thing I kind of like to refer to this one as is it kind of looks like a volcano. So when you have a quantity squared in the denominator, it makes a volcano type of a look. So as you can see, our vertical asymptote is in there at x equals 1. Here's our vertical asymptote. And then our horizontal asymptote, as you can see, this gets closer and closer to the y-axis, but it never touches it. If you want to check that using our table, you can scroll up and scroll down, and it gets closer and closer and closer to 0, but it never hits 0 on the nose. Same thing if you kept on scrolling down. You would keep on getting closer and closer to 0, but it would never ever touch it. So, from here, what we're going to do is we're now going to say that our horizontal asymptote is y equals 0. We'll draw that in there. And now we're going to draw 2 points to the right of my vertical asymptote and 2 points to the left of my vertical asymptote. We're going to find those on our graphing calculator. So these 2 points are left of my vertical asymptote at negative 1, up 1, and at 0, 4. Negative 1, up 1, and at 0, 1, 2, 3, 4. So these 2 points I'm going to connect, and they're going to follow my asymptotes. And now I'm going to do the same thing on the other side at 2, 4, and 3, 1. 2, 4, and 3, 1. Right 2, up 1, 2, 3, 4, and at right 3, up 1. And you could always check these by making sure that they look right on your graphing calculator. They should match up and look pretty similar. So that is what we have for problem number 2D. So hopefully my expectations are clear on what I expect from you on a test. I need to see the vertical asymptote, horizontal asymptote, and the removable discontinuity just like this. I need to see vertical asymptotes and horizontal asymptotes in dotted lines, like this red and this blue. And I need to see these 2 points to the right of the vertical asymptote and these 2 points to the left of the vertical asymptote, and then connect those 2 points together by following your asymptotes. Hopefully that makes sense. Be sure to let me know if you have any questions on those graphing rational graphs, rational functions.